At the heart of our solar system's outer frontier, a massive world reigns supreme. It's more than twice as massive as all the other planets combined. It's wrapped in raging storms, ringed by dozens of moons and cloaked in mystery. This is Jupiter, the king of the planets, a gas giant so immense it could swallow 1,300 Earths. But Jupiter isn't just big, it's powerful. Its gravity shapes the orbits of planets and asteroids. Its radiation belts are deadly. Its moons may be hiding subsurface oceans and even the building blocks of life. In this video, we'll explore the true nature of Jupiter, how it formed, what it's made of, the violent weather systems in its upper atmosphere, and the role it plays in the solar system's evolution. This is the story of the fifth planet from the Sun, a world of gas, gravity, and galactic influence. Jupiter is the fifth planet from the Sun, orbiting at a distance of about 778 million kilometers, or 484 million miles, more than 5 times farther than Earth. It's a gas giant made mostly of hydrogen and helium, the same elements that fuel stars, and it's absolutely massive. Jupiter's diameter is 142,984 kilometers, about 11 times the size of Earth. But it's not solid. There's no rocky surface to stand on. Jupiter is made of layers of gas and liquid that transition slowly toward a dense, pressurized core. Its mass is 318 times that of Earth. In fact, if Jupiter had been about 80 times more massive, it could have become a star, igniting fusion in its core and shining with its own light. But even as a planet, it exerts incredible influence. It spins rapidly, completing one rotation every 9 hours and 55 minutes, making it the fastest spinning planet in the solar system. This rapid rotation causes the planet to flatten at the poles and bulge at the equator, giving Jupiter its distinctive oblate shape. That speed also fuels one of its most iconic features, bands of cloud systems that wrap the planet in stripes. These bands rotate in opposite directions and host some of the most extreme weather anywhere in the solar system. Jupiter's atmosphere is like nothing else in the solar system. It's thick, deep and chaotic, filled with swirling clouds, jet streams, lightning and storms that rage for centuries. From space, we see Jupiter's distinctive bands, alternating stripes of light and dark clouds that circle the planet. These bands are driven by powerful jet streams, reaching speeds of over 400 kilometers per hour. The light-colored zones are areas of rising gas, while the darker belts are regions where gas sinks back down. They rotate in opposite directions and interact at their boundaries, creating giant swirling vortices. The most famous of these vortices is the Great Red Spot, a gigantic storm that's been raging for at least 350 years, possibly longer. It's a high-pressure system spinning counterclockwise in Jupiter's southern hemisphere. At its largest, the Great Red Spot was more than 3 times the size of Earth. Today it's shrunk, but it's still massive, easily large enough to engulf our planet. Why is it red? The answer's still debated. It could be due to chemical reactions in the upper atmosphere involving ammonia, sulfur, and solar radiation, creating reddish organic compounds. Winds inside the storm reach up to 430 kilometers per hour, faster than the strongest hurricanes on Earth. And unlike hurricanes, the Great Red Spot isn't fueled by ocean heat. It's sustained by internal planetary heat and surrounding jet stream interactions. But the red spot is shrinking. Over the last century, it's gotten smaller and taller, possibly a sign of a slow, long-term decay. Whether it will vanish in our lifetime remains a mystery. The clouds we see are just the uppermost layer of Jupiter's deep atmosphere. These clouds are made of ammonia crystals, ammonium hydrosulfide and water vapor, forming 3 major cloud layers stacked above a sea of gas. Beneath those clouds, temperatures and pressures rise rapidly. Eventually, the gas transitions to a supercritical fluid, a strange state of matter that's not quite a gas or liquid, composed mainly of hydrogen. Jupiter has no solid surface. As you descend, the pressure grows so intense that hydrogen becomes metallic, creating a vast ocean of liquid metallic hydrogen, a material that only exists under extreme conditions and is capable of conducting electricity like a metal. This metallic hydrogen layer is believed to generate Jupiter's powerful magnetic field, one of the strongest in the solar system. Jupiter's storms aren't just big, they're electric. NASA's Juno spacecraft discovered that lightning bolts on Jupiter are up to 10 times more energetic than those on Earth. These flashes occur in the water cloud layer, deep within the planet's atmosphere, especially near the poles, where rising warm gas fuels convection. The presence of lightning tells us that Jupiter has weather cycles, including cloud formation, moisture movement and electrical storms, much like Earth, but on a vastly larger scale. The top of Jupiter's cloud deck may look peaceful from orbit, but below it lies a planet in constant violent motion. Jupiter doesn't just dominate space with its size and gravity. It rules over an entire miniature solar system of its own. As of now, Jupiter has at least 95 confirmed moons, and counting. Some are just small chunks of rock and ice. Others are world-sized, complex, active, and potentially life-bearing. The 4 largest are called the Galilean moons, discovered by Galileo in 1610. Each one is unique. Each one could be the star of its own documentary. First is Io, the most volcanically active body in the entire solar system. Io's surface is covered in hundreds of volcanoes, some constantly erupting, spewing molten sulfur and ash hundreds of kilometers into space. Why so active? Io is caught in a gravitational tug-of-war between Jupiter and its neighboring moons, especially Europa and Ganymede. This creates intense tidal forces, flexing Io's interior and generating enormous internal heat, enough to power constant geological activity. Its landscape is colored in yellow, orange and red, painted by sulfur compounds and lava. Standing on Io would be like standing in the middle of an erupting alien furnace. Next is Europa, one of the most intriguing places in the solar system. On the outside, Europa is a ball of rock wrapped in a smooth shell of ice. But beneath that ice is something extraordinary, a global subsurface ocean. Scientists believe Europa's ocean contains more water than all of Earth's oceans combined. It's kept liquid by tidal heating, just like Io, and is sealed beneath 15 to 25 kilometers of surface ice. And where there's water, there could be life. Europa's icy crust is crisscrossed by cracks and ridges. Some areas show signs of geysers or plumes, suggesting water occasionally blasts through to space. Future missions like NASA's Europa Clipper aim to explore these possibilities, scanning the surface and searching for chemical signatures of life. Europa may be one of the most promising places to find life beyond Earth. Then there's Ganymede, the largest moon in the solar system. It's even bigger than the planet Mercury and has its own magnetic field, the only moon known to generate one. Ganymede's surface is a mix of ice and rock with ancient craters and ridged terrain shaped by internal forces. Beneath its icy shell may lie another subsurface ocean, though deeper and less accessible than Europa's. Its sheer size and internal complexity make it a key target for the ESA JUICE mission, which will orbit Ganymede after a flyby tour of Jupiter. Last of the 4 giants is Callisto, a battered, icy world with the oldest surface in the solar system. Callisto is heavily cratered, with no sign of geological activity, but that doesn't mean it's boring. Its interior may still harbour a hidden ocean, and its distance from Jupiter means it's relatively protected from intense radiation, making it a potential site for future human missions or outposts. Some space scientists have even suggested building a base on Callisto as a stepping stone for deeper exploration. Together, the Galilean moons offer a staggering variety of conditions: volcanic heat on Io, liquid oceans on Europa, magnetic fields on Ganymede, ancient ice on Callisto. Each one challenges our understanding of what moons can be, and each may hold secrets about the evolution of planets and the possibility of life beyond Earth. Jupiter isn't just a giant ball of gas with big moons. It's also surrounded by rings, wrapped in an invisible magnetic force field, and it subtly influences nearly everything in the solar system. Yes, Jupiter has rings. Most people associate rings with Saturn, but Jupiter has rings too. They're just harder to see. Jupiter's rings were discovered in 1979 by Voyager 1. They're made mostly of dust, not ice like Saturn's. These particles are kicked up by micrometeoroid impacts on Jupiter's small inner moons, especially Amalthea, Thebe, and Metis. The ring system has three components: the main ring, narrow and flat, about 30 kilometers thick; the halo ring, a thick, faint cloud surrounding the main ring; the gossamer rings, two broad, transparent bands extending farther out, linked to the orbits of Amalthea and Thebe. They may not dazzle like Saturn's rings, but they hint at the violent micro-impacts that constantly reshape Jupiter's space environment. Jupiter has the most powerful magnetosphere of any planet in the solar system. Generated by the movement of metallic hydrogen deep inside, its magnetic field is 14 times stronger than Earth's and extends up to 7 million kilometers towards the Sun, and tens of millions into space on the night side. This magnetic field traps charged particles, forming intense radiation belts that would fry unshielded spacecraft. Jupiter's radiation zone is so dangerous that any human mission would need massive protection just to survive flybys. In fact, NASA's Juno spacecraft uses a titanium vault to shield its electronics as it dives through Jupiter's radiation. The magnetosphere also interacts with the solar wind to create auroras at Jupiter's poles, massive glowing bands of light more powerful than anything seen on Earth. Jupiter the Protector and the Predator. Jupiter's gravitational pull doesn't just affect its own moons. It affects the entire solar system. It acts as a kind of cosmic shield. Its massive gravity deflects or absorbs comets and asteroids that might otherwise strike the inner planets, including Earth. But it's also a cosmic sculptor. Jupiter's presence helped shape the asteroid belt, preventing a planet from ever forming there. Its gravity also influences the orbits of Trojan asteroids that share its path, as well as many objects in the Kuiper belt far beyond Neptune. In rare cases, Jupiter can even fling objects toward the inner solar system, changing the trajectories of comets and possibly triggering impacts. So is Jupiter our protector or our greatest risk? The answer is both. Even today, Jupiter's gravity continues to steer comets and asteroids, both protecting Earth and occasionally throwing debris our way. In fact, Jupiter's powerful pull helped trigger the Shoemaker-Levy 9 impact in 1994, when a fragmented comet slammed into the planet's atmosphere, creating fireballs larger than Earth itself. It was the first time humanity had ever witnessed such a dramatic planetary collision, and a stark reminder of the role Jupiter plays as both a shield and a slingshot. Because of its size, composition and position, Jupiter is the template for gas giants everywhere. Many of the exoplanets discovered orbiting other stars are hot Jupiters, gas giants found much closer to their stars than ours. By studying Jupiter, we not only learn about our solar system's past, we gain insight into the formation of planetary systems everywhere. Jupiter is the king of planets, but beyond it lies a frozen world with rings even more magnificent, and secrets locked in methane seas. Like and subscribe to join us next time on Skyward Space Quest as we journey to Saturn, the jewel of the solar system.